Welcome to the DIY Honda Garage channel. The DTC P2646 indicates a malfunction in the rocker arm oil pressure switch circuit due to low voltage. This switch is crucial for the VTEC, variable valve timing and lift electronic control system, ensuring appropriate oil pressure transitions between different operating modes. Its location is typically near the engine cylinder head, connected to the engine's wiring harness. When this circuit experiences low voltage, the system cannot function optimally, leading to potential performance issues. Proper diagnostics are critical to identify the fault source effectively. This could involve checking electrical connections, oil levels, and component functionality to determine the underlying issue before deciding on repairs or replacements. Error DTC P2646 defines a low voltage condition in the rocker arm oil pressure switch circuit, impacting the VTEC system's operation. The rocker arm oil pressure switch serves as an electronic valve controller, regulating oil pressure to critical components in the engine for enhanced performance. Located near the cylinder head, its placement is strategic for immediate access to oil flow and pressure readings. If this switch fails or sends inaccurate readings due to low voltage, it generates DTC P2646, signaling potential issues within oil circulation or control. This circuit is vital for maintaining the engine's efficiency and responsiveness across varying RPMs and conditions. Understanding this component's role and location aids in systematic troubleshooting. Several causes can lead to DTC P2646, primarily focusing on oil pressure and electrical components. Firstly, a low oil level can lead to inadequate lubrication and pressure, causing the switch to report low voltage. Secondly, if the rocker arm oil pressure switch itself is malfunctioning due to age or damage, it can falsely signal low voltage conditions to the engine control unit, ECU. Lastly, wiring issues, such as short circuits or poor connections between the switch and the powertrain control module, PCM, can disrupt the voltage supply. Identifying the exact cause is essential to prevent further damage or performance loss within the engine and related systems. A comprehensive evaluation of oil levels, switch integrity, and wiring continuity is crucial. The symptoms associated with DTC P2646 can significantly affect vehicle performance and driver experience. First, the most immediate sign is the illumination of the check engine light on the dashboard. This alerts the driver to potential issues requiring attention. Power loss during acceleration can also be a noticeable symptom, as the VTEC system may fail to engage correctly, resulting in sluggish performance. Additionally, abnormal engine noise may manifest as the system struggles to maintain appropriate oil pressure, impacting the engine's operational smoothness. Recognizing these symptoms early can help in timely diagnostics and repairs, potentially saving from more severe engine issues and ensuring optimal performance. The first step in troubleshooting DTC P2646 involves verifying the engine oil level. Proper oil levels are crucial, as insufficient oil can lead to inadequate lubrication, ultimately causing low voltage conditions in the rocker arm oil pressure switch circuit. Therefore, it's essential to check the dipstick to confirm whether the oil level is within the recommended range specified by the manufacturer. Should the oil level be low, topping it up to the correct level is necessary before proceeding. If the oil level checks out, the investigation transitions to other components and systems. This initial verification is pivotal, as addressing simple oil level deficiencies can often resolve performance concerns without needing more complex diagnostics. In the second troubleshooting step, the vehicle must be placed in the on mode without starting the engine. This action prepares the onboard diagnostics tool, HDS, for further checks. After ensuring the vehicle is in the correct mode, the next task is to clear any stored diagnostic trouble codes, including DTC P2646. Clearing the codes allows for fresh data to be collected during subsequent testing phases without historical errors clouding results. Following this step, it's crucial to perform a VTEC test via the HDS's inspection menu. The results of this test will either confirm intermittent failures or point to a possible duplication of the error, guiding the technician to the next necessary action. In troubleshooting step 3, the process requires turning the vehicle off before disconnecting the rocker arm oil pressure switch's 2P connector. This step will isolate the switch from the circuit, so its functionality can be independently evaluated. Subsequent to disconnection, the instrument panel will be restarted, and diagnostic parameters will be monitored using the HDS. The technician will observe the performance readings, particularly focusing on the VTEC pressure switch status. If these values fall within expected thresholds, the next steps will be initiated. Conversely, anomalies at this stage mean further exploration of the circuit, including parameters relevant to voltage and ground connections, must ensue to narrow down the fault. Troubleshooting step 4 demands a more hands-on approach with components, starting by switching the vehicle to the off mode. The next critical action involves removing the rocker arm oil pressure switch from its mount. To correctly assess the oil pressure, special tools must be utilized. These include the pressure gauge adapter and the oil pressure gauge, which must be correctly attached as specified in the diagnostic data. After securely connecting the gauge, the ignition is turned on and the engine is started to allow for testing. Conducting the VTEC test once the engine is running helps capture real-time oil pressure readings. If the pressure reaches the specified value of 392 kPa, or approximately 56.9 psi, it's time to replace the rocker arm oil pressure switch. Otherwise, further inspections within the VTEC system should commence. The final troubleshooting step involves ensuring electrical integrity within the wiring associated with the rocker arm oil pressure switch circuit. This begins with the vehicle turned off and the SCS line being jumped with the HDS to prepare the vehicle for testing. After this, the PCM connector, C51P, is disconnected to isolate the connection points for the continuity test. The technician then checks continuity between designated test points, specifically between the PCM connector and body ground. A successful continuity signal suggests there is an issue, such as a short within the wiring leading between the PCM and the switch, signaling the need for repairs. If no continuity is found, it indicates the wiring is intact, paving the way for PCM updates or substitutions if necessary. After repairs have been performed for DTC P2646, undertaking a final verification step is essential. Commonly, this includes a thorough test drive of the vehicle, ideally under conditions that might have previously triggered the issue. During this period, the technician should closely monitor the engine performance, looking for any hesitation, power loss, or other symptoms that could hint at unresolved issues. Following the test drive, utilizing the HDS again to check for the reappearance of DTC P2646 is critical. If the code does not return, the troubleshooting efforts can be considered successful, ensuring that the VTEC system and rocker arm oil pressure switch components are functioning as intended. To prevent the recurrence of DTC P2646 and ensure long-term reliability of the engine's VTEC system, adherence to a stringent preventive maintenance schedule is paramount. Regular oil changes, based on manufacturer recommendations, not only keeps oil levels adequate, but also ensures that the oil quality remains optimal, reducing sludge and contaminants. Moreover, the monitoring of engine performance can provide early warnings of sensor failure, wiring issues, or oil pressure concerns. Periodic inspections of electrical connections associated with the rocker arm oil pressure switch and the overall VTEC system can help identify wear or potential faults before they evolve into serious issues. Establishing a routine check regimen can maximize engine efficiency and minimize repair costs in the future. In summary, DTC P2646 emphasizes the importance of monitoring and maintaining the rocker arm oil pressure switch and its circuit. Identifying symptoms early, such as reduced power or engine noises, allows for prompt diagnostics, potentially preventing more significant damage. Following a systematic troubleshooting approach, as outlined in previous steps, leads to an effective identification of the underlying causes, whether involving oil levels, wiring, or component failure. Ensuring that all repairs are verified and practicing preventive maintenance can foster optimal vehicle performance and enhance the longevity of the engine. Understanding the role of each component, along with rigorous checks, will ensure that the vehicle operates efficiently, thereby improving the ownership experience. Please like and subscribe to the channel. See you next time.